Hello, and welcome to my presentation. My name is Amanda Paton, and today I'm going to be talking about the Parcel Fabric and how we used it to comply with New Jersey tax map submission standards. First, let me tell you a little bit more about myself. I'm a GIS technician at Mazer Consulting. I have over 3 years experience in GIS data creation and design with an emphasis on land records and creating tax maps. My expertise include creating and maintaining GIS geodatabases, managing parcel data, creating tax maps, and managing replicated databases for multi-user editing. I have bachelor degrees in GIS, planning, and geography, all from Rowan University. Next, let me give you a little background on tax maps. Property taxation in the U.S. dates back to the original Pilgrims in Plymouth, Massachusetts. They created laws regarding taxes and assessments of a fort that they built. The first tax mapping originated in the 1670s in Boston, and it listed assets and values. Tax maps used to be hand-drawn on linen, and then this later progressed into mylar. Both of these had the risk in decline in durability and readability because they could rip or smudge easily. They both also had the risk of human error because they were hand-drawn in the field. This could skew the courses. Both of these also took up a lot of space, having to keep the copies and revisions all in paper form. The New Jersey Division of Taxation has prescriptive standards, so much so that they have a manual of standards that is very specific. It outlines line thickness, text sizes, and how things should appear in various situations, such as condos, paper streets, vacated streets, water bodies, easements, and others. Tax maps in New Jersey are typically prepared using CAD, but we are using GIS technology to meet these standards while also updating land records which were out of date. Having the parcels in GIS will make the process of maintaining these land records so much easier. The tax maps we created were for the city of Elizabeth, New Jersey. Elizabeth is one of the largest cities in New Jersey. It has almost 130,000 people and covers almost 13.5 square miles. The final tax map set had almost 20,000 parcels and 234 tax map sheets. The city of Elizabeth is a very diverse city. It has everything from small streets to industrial facilities, commercial and retail areas, parks, highways, the Elizabeth River, railroads, a port, and an airport. The top image on the left is a sheet from the 1930 set of Elizabeth tax maps, and the top image on the right is an aerial view of the port and airport in Elizabeth. The landscape in New Jersey is ever-changing, and there's redevelopment everywhere you look. For this reason, keeping accurate property records is essential. It is important to maintain these tax maps with as much accuracy and consistency as possible so that property owners can be properly taxed. Using GIS for tax maps is a relatively new concept, but there are a lot of benefits associated with it. The first one I'll mention is accuracy. They're not hand-drawn, so you don't have to worry about all the risks associated with that. Another is practicality. They are stored digitally, printed when necessary, and therefore take up less physical space. You can create a seamless parcel network. You can use attributes to keep information about the parcel, and then you can use that information to search for a parcel or join it to another database. Since it's in GIS, we have it georeferenced, so you can turn on an aerial or add other data to your map to see how it compares to your parcels. Using GIS allowed us to use version databases, which allows for multiple simultaneous editors. And having land records in GIS lends itself to current web GIS, so we can use asset management. The parcel fabric is made up of points, lines, and polygons. It is a continuous surface of connected parcels or a parcel network. The image to the left is what the parcel fabric looks like in your table of contents. You'll notice that we are using ArcMap and not ArcGIS Pro. This is because we started the project in late 2017 and at this point, ArcGIS Pro had not rolled out all of the tools for the Parcel Fabric. Some of the benefits of the Parcel Fabric are that it offers a way to maintain a seamless surface of connected parcels in one dataset, so there are no gaps or spaces, and it has a much more accurate scale. Another benefit is the historic lots. As lots are consolidated or subdivided, the original lot is given an end date, and it is then stored in the historic parcel layer of the Parcel Fabric. This allows us to see what an area was like before a major subdivision or other change. When redevelopment is always occurring, this is an important tool. The right image, you can see that the red hatched area is now a historic parcel because it was subdivided into two new parcels. The Parcel Fabric also allows us to store plans, which is the legal recorded document that describes the parcel. It stores this information in the plan directory. When a document containing specified survey points is available, they can be used as control points in the Parcel Fabric to build the parcels around that specified known point. Control points are defined by X and Y coordinates. They are more accurate than the Parcel Fabric points, and for that reason they may not always match the Parcel Fabric point. Adding more control points will continuously improve the positional accuracy of the tax parcels throughout the city. Our workflow was created with Esri and consisted of some preliminary drafting and georeferencing of the tax maps, which took place in CAD. Then the raw CAD data was migrated to GIS, cleaned up, and converted to polygons. GIS attributes were then populated and the data was polished. Some of the attributes that we included were block numbers, lot numbers, and sheet numbers. All of this was prior to the creation of the individual tax map sheets. The left image shows some of the important attributes that can be found when you click on a parcel. Some of the software that we used includes ArcGIS Desktop, Enterprise GIS, AutoCAD Civil 3D, Nearmap, and ViewWorks. Here's a list of some of the main geoprocessing tools that we use throughout our process. I'm only going to get into the details on a few of them, but if you have questions, feel free to contact me or if you want more information. We used feature class to feature class to get the CAD line work to GIS. We used make a feature layer and feature to point to get the annotation from CAD to GIS and then be able to use it as attributes for the parcels. We used topology rules to clean up the CAD line work and make sure that we could create closed polygons. And spatial joins were used to add the block numbers to the parcels. The City of Elizabeth was hand-drawing updates to a 1930s set of tax maps. There were about 30 years of updates that needed to be made from when the CAD tax maps were created. The old 1930s set of tax maps had different block and lot numbers than the CAD set, and the city wanted to update their numbers both in the tax maps and in their tax assessment database to match the numbers from the CAD set. This required us to create a cross-reference database of the old and new numbers in the tax assessment database. Properties that required updates were located by comparing the two tax map sets, and then the edits were made in the new parcels that we created in GIS. Edits were made to the Parcel Fabric based on filed deeds. Numerous updates and edits needed to be made to the parcels, so it made sense that multiple people would work on this project. To do this, we used versioning of an SDE database and replication to allow for multiple editors. The image shows an example of what our version database could look like. There were several different types of edits that needed to be made to the parcels. One was subdivisions, in which we could use construct from parent, and from there we could add a parallel offset or a break line, depending on how simple or complex the subdivision was. Another edit was consolidations, in which we could select two or more parcels and merge them together. Other times the CAD line work was inaccurate, and we would have to move a point like a vertice using the transform tool. And this would in turn move the neighboring parcel that shared that vertice. This is how the seamless parcel network is maintained. In areas where it was just new development, we would have to create a new parcel. The left image shows how you can access some of these tools. If you right-click on a parcel using the parcel selector, you get the option to construct from parent. If you had more than one parcel selected, you could merge them together. If you wanted to access the transform or new parcel options, you would have to use the parcel editing toolbar. The image to the right is showing some of the other tax map updates that we encountered throughout this project. Creating the tax map sheets. The image to the left is a final tax map sheet that I created for the City of Elizabeth, and this is what the final sheets look like. There are 234 sheets, plus an index sheet and 6 key sheets, and each sheet had its own MXD. New Jersey has a unique requirement for how tax maps need to be displayed by blocks such as right-of-ways, where the rest of the world uses a grid form. The image shown here on the bottom of the sheet, there are lots that continue in each of those blocks, but they are not shown on this sheet. They are shown on the connecting sheet. You can't have duplicate parcels on separate sheets. Definition queries were used to ensure that we were only showing those parcels that were necessary on that sheet and prevent showing duplicate lots on separate sheets, which would not be in compliance with the state standards. Without attributes, definition querying would not be possible. Sheet boundaries were created to clip the extent of the data that was shown in the data frame and provide a buffer between where the lines of data ended and where the sheet border was. We faced a number of project challenges along the way. One was that we can't display a full grid map, so attributes and definition queries had to be used to limit the data that was shown on each sheet. Another was the updating of the block and lot numbers. The numbers had changed since the 1930s, and they switched over to a new numbering system. These had to match up to the block and lot numbers that were in the tax assessment database, so we had to create a cross-reference list. There was also a lot of properties that were not identified up to state standards, but the attributing and cross-reference list helped us find these missing properties. We were able to join the tables and find properties that didn't have matches. Your list of parcels needs to match your tax assessment database. Using GIS allowed us to assist the city's tax assessor with identifying and resolving any issues that may have existed in the tax assessment database. This was a big project, and there was a lot of work that needed to be done on a tight timeline. We used versioning to allow for multiple editors to speed up this process. Some other benefits to using GIS for tax maps is that you can then use that GIS data that we created in other ways. You can use joins to link the parcel data to the tax assessment database, which contains owner information, property information, and other tax information. You can overlay other data, such as flood data. The flood hazard lines are actually needed on the tax maps, so this was very beneficial in our case. You can also overlay data for other reasons, such as wetlands, voting districts, zoning data. Having the parcels in GIS will also now allow us to use them for asset management, such as property upkeep through ArcGIS Online, Survey 123, Operations Dashboard, or others. We have the data served into ViewWorks, which is an Esri partner that offers off-the-shelf eGIS asset management programs, which we are currently training the city on so they can access their tax map data. GIS should be the new standard for creating tax maps. Thank you for watching my presentation. Again, my name is Amanda Paton. If you have any questions, my contact info is listed here.